In example 3 from notes 2.7, we are going to look at inverse relations numerically and graphically. So an inverse relation interchanges the input and output values of the original relation. Remember, relation is a mapping of input and output values. A function is a special type of relation in which each input is matched to exactly one output. So here we're just talking about relations, not necessarily functions. All right, so we're given an original relation. We're given a set of inputs and outputs. The inverse relation is going to interchange input and output values. So if the original relation had an input of 0 and an output of 6, the inverse relation is going to have an input of 6 with an output of 0. So I'm going to interchange all the x and y values from the original to the inverse. So 0, 6 goes to 6, 0. 1, 4 is going to go to 4, 1. 2, 2 is going to stay 2, 2, but we're really switching those two 2's. The original relation had an input of 3 and output of 0. The inverse relation is going to have an input of 0 and output of 3. And in my original relation, I had an input of 4 and output of negative 2. The inverse is going to have an input of negative 2 and an output of 4. I'm going to go ahead and graph the points on the original relation and on the inverse. So the original relation I'm going to plot in red. So I'm going to plot the point 0, 6, 1, 4, 2, 2, and 3, 0, and 4, negative 2. Those were the points on my original relation. I'm also going to plot the points on my inverse relation. So I'm going to have the point 6, 0, 4, 1, 2, 2, 0, 3, and negative 2, 4. Okay, so I plotted those points. And let's go back and state the domain and range for the original and inverse relations. So the domain of the original relation is simply the set of x values. So 0, 1, 2, 3, 4. And the range is the set of y values. So I'm going to put those in ascending order. So negative 2, 0, 2, 4, and 6. For the inverse relation, the domain is the set of inputs. So that's going to be negative 2, 0, 2, 4, 6. I'm taking that from the inputs here. And the range is going to be the set of outputs. So 0, 1, 2, 3, and 4. Okay, now we have all the information set up. We're going to try to draw some conclusions. So what do we look about? Let's look at the domain and ranges of the two functions. If we look at them, we'll see that the original relation and the inverse swap domain and range. So the domain of the original function is the same thing as the range of the inverse function, and the range of the original function is the same as the domain of the inverse function. And we saw that on the previous example. Now let's go over here and look at the graph. So if we're looking at the graph of the function, what do we notice about the graph of the original, which was the points in red, and the graph of the inverse relation, which is the points in blue? And you'll notice that I have this line y equals x drawn on here. This has something to do with the conclusion that we can make. So if we look at it and we consider y equals x a mirror, we can see that, let's take a point, for example. Let's take the point 0, 6. 0, 6, if I mirror that in the line y equals x, I would come down and I would get the point 6, 0. Likewise, if I take the point 1, 4 and I mirror that in the line y equals x, I get the point 4, 1. 2, 2 is already on the line y equals x, so that mirrors itself. If I take the point 0, 3 and I mirror that in the line y equals x, I get the 0.31. And similarly for negative 2, 4, if we reflect that in the line y equals x, we're going to get the point 4, negative 2. So the conclusion that we can draw is that, can you draw a conclusion about the relation between the graph of a relation and its inverse? So those are a conclusion about the original relation, which were the red points, and the inverse relation, which is the blue points, or which are the blue points. And the conclusion is that they are reflections in the line y equals x. So if we have two relations and they are indeed inverses, they will be reflections of each other in the line y equals x. Okay, what happens if we're just given a point? So if we know that a point AB lies on a function, what point will lie on the inverse function, on f inverse of x? We know that an inverse switches inputs and outputs, so therefore we can say the point B comma A will be on the inverse. That means it's going to switch x and y values. That's what an inverse does. And here's something else that we can do at the bottom. Since f inverse is the reflection of f in the line y equals x, we can actually verify this, that two functions are inverses, by examining their graphs. This is not the way we're really going to verify inverse functions, but if we look at something graphically, we can get an idea. We can use our graphing calculator, graph both functions, and also we can graph the line y equals x, but you're going to want to use a square window. And to do that, you can do zoom, I think it might be zoom B square. And that will make a square window where it's easier to see that two graphs are reflections of each other.